In the last video, in the previous set of videos, we talked about how we can plot complex numbers in like an XY plane. So if we have z is, let's say, 2 plus 3i, we can say, okay, 2 ticks on the x-axis, 1, 2, 3 ticks on the z-axis. And so we can think of this point right here as corresponding in the xy plane to z is equal to 2 plus 3i. And so to tie this in to things that we've done in Calculus 2 so far, we can also, as the title of the slide says, we can think about polar coordinates for complex numbers. That instead of writing z is equal to x plus iy, we can think of z as a pair r and theta, where r is exactly r from polar coordinates, the distance you are from the origin, and theta is exactly what you would think of in polar coordinates. It's the angle you are from the positive x-axis. So this distance here would be the r, that angle there would be the theta. And the equations to convert a complex number to polar coordinates are exactly what you would expect them to be. So we're writing z is equal to x plus iy. R is just the modulus of z using complex numbers term, and that just is, of course, the square root of x squared plus y squared. How do we get theta? Tangent theta is equal to y over x. So depending on, these first two cases are just basically, which quadrant are you in? So if x is positive, you're in quadrant 1 or 4, theta is just arctangent y over x. If x is negative, you're in quadrants 2 or 3, theta is arctangent y over x plus pi. And if x equal to 0, depending on if you're on the positive or negative x-axis, positive or negative y-axis, I should say, theta is going to be plus or minus pi over 2. But we will always, one important thing is that we will always want r to be non-negative here. So when we do polar coordinates, occasionally we would allow r to be negative and reflect through the origin. Here we do always want the modulus of z, which is going to be our r here, we never want that to be negative. Okay, but let's just do a couple examples here. So for example, if we were to have z is negative 2 square root 2 plus 2 square root 2i, so two kind of parts here, convert this polar coordinates and plot it. So for the r, it's just going to be the modulus of z, which is the square root of the x component squared plus, sorry, I should just say the x component squared. Oh, sorry, that's what I meant by the square root there, plus the y component squared, and that's going to be 8 plus 8, the square root of 16 is 4. And then what is going to be theta? So we need to compute arctangent of y over x. And so that's going to be arctangent of -1. The arctangent of -1 is negative pi over 4. However, we have to be careful. Here, we are dealing with x is negative. And so we are not in theta's arctangent of y over x. We're not in that case. We're in x is negative, theta's arctangent of y over x plus pi. And so that's why I didn't say theta is equal to this. Theta is equal to arctangent of y over x plus pi. So minus pi over 4 plus pi is 3 pi over 4. And if we graph that, so that would be this point off over here. So the coordinates there would be -2 root 2 and 2 square root 2. The length of this line segment, that would be r is equal to 4. And this angle there, theta, is equal to 3 pi over 4. And so that all checks out. Let me just do a couple other quick hits here. And we're thinking of z is equal to, let's say, -1. So that's equal to -1 plus 0 times I. What happens in this case? So we would need to compute theta's arctangent of y over x. Well, first off, r is modulus of z. That just ends up being 1. Theta would be arctangent of y over x plus pi, because again, x is negative. Arctangent of 0 is 0, so this is just pi. So the r theta is just 1 comma pi, which of course that makes sense. You know, we are over here at -1 comma 0. And then one final example real quick. If something is pure imaginary, z is equal to, let's say, -2i, which would be 0 minus 2i. The modulus of this would be 2. Check that for yourself. Theta, in this case, x is equal to 0. Theta is either plus or minus pi over 2. And it's going to be, in this case, negative pi over 2. How can we tell that? Just by plotting it here, that, you know, -2i is down here. So this angle would be negative pi over 2. You could also write that as 3 pi over 2. That would both be, those would both be correct. R has to be 2. Okay, so yeah, so we'll definitely do more about these polar representations in the future, but you know, the skill from this video, if I give you a complex number, you should be able to go to polar coordinates.